Hi guys, welcome to our channel Helm of Science. I had been discussing the chapter heat with you guys in my last few videos. So in this video I'd be discussing few of the most important questions that are asked from this chapter heat. So let's get started. So the first question which is commonly asked is that when two bodies at different temperature are kept in contact, state the direction of flow of heat energy. So let us consider that body A is at a temperature, let's say 40 degrees Celsius. Another body which is B is kept at a temperature 20 degrees Celsius. So the two bodies are kept in contact and are at different temperatures, which is 40 and 20. So in my first video I had explained that heat energy always flows from a body which is at a higher temperature to a body which is at a lower temperature, which is 20 in this case. So we will write that heat, okay, the answer to this question should be heat energy always flows always flow from the body at high temperature to the body at low temperature. Now moving on to the next question. Question number 2 states that ice cubes, when touched with hand, appear to be cold. Explain. Now the answer to this question also applies the same concept which was discussed in the previous question. So we know that heat energy always transfers from a body at higher temperature to a body at lower temperature. In this case the ice cube is at the lower temperature and our hands are at a higher temperature, so heat will flow from our hands to the ice cubes, hence we feel cold when we touch the ice cube. So it flows from our hand to the ice cubes. This is because our hands are at a higher temperature and the ice cubes are at a lower temperature. As heat flows from our hands, so we feel cold. So this is the simple explanation to this question. It is very commonly asked in your exams. So moving on to the next question. State two substances which expand on heating. Now substances generally expand on heating, right? This is the common phenomena which takes place. Substances expand on heating unless we know that few substances like water and silica discuss exhibit anomalous expansion, so they contract on heating, but normally substances expand on heating. So you can write any metals, like metals expand on heat, right? So you can write any metal name like iron, brass, copper, anything you can write, copper, anything. So Next question says that two substances which contract on heating. Now here you will write examples of those substances which exhibit anomalous expansion. I had discussed water with you guys. What is a common example where water exhibits anomalous expansion, that is it contracts on heating between the temperature range of 0 degrees Celsius to 4 degrees Celsius. This is very common, we have discussed this. I had also discussed in my video about silica which exhibits anomalous expansion. Now in this question I'll discuss another substance like silver iodide also exhibit the same anomalous expansion within the temperature range of 40 degrees Celsius to 181 degrees Celsius. So within this temperature range, silver iodide exhibits anomalous expansion. Now this was our fourth question. Now moving on to the fifth one. Moving on to the fifth question. At what temperature is the density of water maximum? State the value. At what temperature is the density of water maximum? State the value. So when we drew the curve for the anomalous expansion of water, that is the variation of density with respect to temperature, we saw that the maximum density of water is always observed at a temperature of 4 degrees Celsius. So maximum density is observed for any given mass of water observed at 4 degrees Celsius, and the value of this density, state the value, it is given. So value of this density is 1 gram per centimeter cube. It is 1 gram per centimeter cube, or if you express in terms of kg per meter cube, it is 1000 kg per meter cube. It can be either 1 gram per centimeter cube or 1000 kg per meter cube. Now moving on to the sixth question, I suppose. Yeah, sixth question. State the volume changes observed when a given mass of water so when a given volume of water I'm sorry given quantity of water is heated from 0 to 10 degrees Celsius. Also graphically show the changes. So now we have discussed that when water is at 0 degrees Celsius and it is heated, so from 0 degrees Celsius to 4 degrees Celsius, we know that water exhibits anomalous expansion. So instead of like normally what happens when we heat, it expands. So during this period, instead of expanding, water, what happens? It contracts. Water contracts. That means its volume decreases. Thus when water is heated from 0 to 4 degrees Celsius, it contracts, thus volume decreases. But during the period of 4 degrees Celsius to 10 degrees Celsius, water exhibits the normal properties, that is it expands, that is volume increases. volume increases, and during the period of 0 to 4 degrees Celsius the volume decreases. Now it is given that we have to graphically show the changes. So if we plot the changes in a graph, in the x-axis we'll keep temperature expressed in degrees Celsius. This is the x-axis. Y-axis will keep volume expressed in gram per centimeter cube. 4, 6, 8 and 10. Now uh, uh, okay, so from 0 to 4 degrees Celsius we know volume will decrease. So volume will keep on decreasing till 4 and reach a minimum. This is the minimum volume, and from 4 to 10 it will keep on increasing. It will, sorry, from 4 it will keep on increasing. So from 0 to 4 the volume will decrease, and from 4 to 10 it will keep on increasing. So and which is the minimum value of volume is 1 gram per cc centimeter cube, which is observed at 4 degrees Celsius. So this is the graphical nature of the volume changes which is observed when a given quantity of water is heated from 0 degrees Celsius to 10 degrees Celsius. So now if we move on to the next question, I believe it's question number 7. So question number 7 says that water tanks in cold countries freeze starts freezing from the top instead from the bottom. Explain. So now water tanks in cold countries starts freezing from the top instead from the bottom. So we know in case of and we know that, let's say that this is a tank, this is the tank which contains water. So the water which is at the, when initially the temperature drops down, so water at the top will start to contract, like, because from, let's say, from it starts cooling from 10 to 0 degrees Celsius, so water will start to contract until it's at 4 degrees Celsius, right? Due to anomalous expansion from 4 to 0 degrees Celsius it will again expand. So from 10 to 4, from 10 to 4 degrees Celsius it will keep the volume will keep on decreasing. So the water will there will be a circulation, so water which is at the top will go down to the bottom, and from the bottom water which is at the bottom layers will go on to the top, and again consequently cool down, and again there will be a circulation of sorts. So and when the water at the top, after the circulation, when it cools down even further, that is from 4 to 0 degrees Celsius, now instead of contraction, the water instead of contraction will now expand. So now what happens is that there won't be any circulation now, because when water expands its density will be decreased. So what happens is that the lower density water will keep on at the top layer, so there won't be any circulation at that time. So and the water will keep on cooling down and cooling down, and the lower density water will eventually form ice and settle down at the top of the pond. And so we say that always freezing starts from the top of the pond, due to the anomalous expansion of water. Now we'll move on to the 8th question. We'll move on to the 8th question. It says that a frozen pond wait one second. There is a frozen pond. State the expected temperature of water, number 1, which is in contact with the which is in contact the upper ice layer, and water which is at the bottom of the tank, at the bottom of the pond, of the pond. So we know that the water which is in contact with the upper layer is ice, so it will be of low density, so the water temperature will be 0 degrees Celsius, and at the bottom of the pond the density will be much more. So like I explained in the previous question, the water will be at a temperature of about 4 degrees Celsius. So if we see that pictorially, let's say this is the pond and this is the layer of ice which is formed because the density there will be initially there will be a circulation. So let's draw it from the first. Initially what happens is that the upper layer cools down till 4 degrees Celsius and it comes down, and water from the lower surfaces will go up, right? So water from the lower surfaces will go up, and again eventually this water from the lower surface will also cool down and come to 4 degrees Celsius, right? So this circulation will stop when the topmost layer of water, which is at 4 degrees Celsius, eventually becomes more cooler, like it cools down further to 0 degrees Celsius. During this period, instead of contraction, like instead of increasing density, it will decrease in density because volume will expand. So it will remain at the top and it will cool down even further to become a layer of ice. So it will settle down at the top as a layer of ice which is at 0 degrees Celsius. So eventually the contact water which is at contact with the ice is also at 0. So if we move down further, it will slightly increase, the temperature will slightly increase. It will be 2 degrees Celsius, 3 degrees Celsius, and eventually it will be at 4 degrees Celsius. So this is the whole procedure. Now moving on to the 9th question, it says that we should not lay electrical wires too tightly between electric poles. Explain. We should not lay electrical wires too tightly between electrical poles. Now we know that like substances contract on cooling, right? They contract on cooling. Metals contract on cooling. So if we lay, let's say these are two electrical poles, pole A and pole B. If we lay a wire too tightly, what happens is that at winter, what happens is the temperature cools down and this metal wire will eventually contract, and if they start contracting, if they are laid too tightly, what happens is that eventually there will be chances of the electrical wires tearing apart. So what happens is that it will tear down if in winter, if the temperatures drop too down. So that's why as substances contract on cooling, they should not be, the wires should not be laid too tightly. Instead, there should be they should be loose, like they must not be too loose, because at some point eventually they will again expand on heating. So it will, if we are laid too, if they are laid too loosely, so it will become more loose. So there must be a minimum little loose, like it won't be too loose, neither should be too tight. So eventually if we lay like this, if we lay the lines like this, it won't be a problem. So in the last question we'll solve a numerical. It says that an iron rod rod of length 5 meter initially at 0°C is heated to 100°C. The value of alpha, which is the coefficient of linear expansion is 0.5 into 10 to the power minus 2 Celsius inverse. And so find the final length of the rod. Find the final length. Now we know from the thermal expansion, we had derived the equation which is LT is equals to L0 1 plus alpha T. We had derived this equation. So LT is the final length, L0 is the initial length, so which is given. So L0 is 5 meters, right? It is given. Alpha, which is the coefficient of linear expansion, is also given, which is 0.5 into 10 to the power minus 2 Celsius inverse. Also T, which is the difference in temperature, is also given. Initially it was at 0, it was heated to 100°C. So T will be also 100°C, which is the difference in temperature. Now these three things are given, we have to find LT. So we have to just replace the values in this equation and we will easily find the value of LT. So if we replace that, therefore by the problem LT equals to L0, which is 5, 1 plus 0.5 into 10 to the power minus 2 again into 100. So this cancels basically, and so we will get 5, 1 plus 0.5, 5 into 1.5, which is 7.5 meters. So the final length of the rod at 100°C will be, final length will be 7.5 meters. So this is your answer. So these were few of the most important questions which are asked from this chapter heat. So if you find this video useful, please like the video, subscribe to our channel and share it among your friends. So see you in the next video with another chapter. Bye.